The video games I played as a teenager rarely had a save function in them. There just wasn't any hardware for it. To save the progress you had to write down a password using a pen and paper. In this series we crack how these passwords work. Kid Icarus is one of those games that exemplifies the title Nintendo Hard. Most people who played it never beat it because it's so hard, at least in the beginning. It is essentially a clone of the mountain climbing formula Nintendo previously used with Ice Climber, also a very difficult game where once you scroll up, you can't go back down and the screen wraps horizontally. But this is only a half-truth. There is actually quite a bit more. There are also side-scrolling sections, where once you scroll right you can't go back left, and mazes, even flying. And there are vendors who sell you stuff for the measly price of some hearts. If you can't afford the things, you can attempt to haggle. If you still can't afford, you can pay with a credit card if your character has one. Of course, then you will have to pay the debt before you can accumulate wealth again. And there's a level and strength system, multiple weapons, and the Eggplant Wizard. The Eggplant Wizard is an enemy that continually hurls brinjals in ballistic arcs. If one of those hits you, you are instantly turned into an aubergine, a luggage-sized literal eggplant. No limbs, no face, just a chunk, a blob. You cannot use any weapons or speak, you cannot defend yourself. Why would you? You are a vegetable now, or a fruit or a berry if you ask a botanist. Ever wondered what happened to those eggplants in Ice Climber? Now you know. But he doesn't even have eyes. That cyan dot is not his eye, it's a specular highlight. What a horrible night to have a curse. Although somehow he can still move. Oh, I guess he does have legs. He can even climb ladders. I mean, how does that work? Hopefully in his mute, deaf and blind stupor, he can reach a hospital where the curse is removed, no questions asked. But when your character eventually perishes, the game gives you a password. Sacred words it calls it, 24 symbols long. Kid Icarus was Nintendo's first own game to have a password. Others, such as Enix, had done it before with their Dragon Quest series, but Kid Icarus might have been the first game released to the Western audience to have a password system. You see, this game was originally developed for the Famicom Disk System. The Famicom Disk System was a Japan-exclusive extension to the game console, where instead of ROM cartridges, the game were supplied on diskettes. These diskettes were both readable and writable. The idea was that you could bring your diskette to a disk writer kiosk and have a new game written to the diskette. But writable means also that the game state could be saved on the diskette. The diskette literally had a save file in addition to the game, well, 3 of them in this case, and a high score table. But when the game was imported to the Western market, there were no diskettes, nor flash drives. They had to change the game to work with ROM cartridges. When one studies the assembler code, many telltale signs of the earlier design are visible. In particular, it treats some portions of the code as if they were files, and copies them from ROM into RAM and executes them there. Oh yeah, they did add extra 8 kilobytes of RAM to the cartridge to help with that. But there was nowhere to save the game. Or was there? The console does not have any writable storage, but the player does, namely paper. So they changed the code such that the save data, 18 bytes long, is converted into base 64 and displayed on the screen as 24 symbols. The player can then later come and enter that same base 64 string, and the save data is restored from that string of symbols. The character set for the passwords is identical to what it was in the Battle of Olympus, which we covered in Season 3, Episode 1. All the decimal digits, the entire English alphabet, and the question mark and the exclamation mark. Each of these 64 symbols is really a number, even though some of them look like letters. Each of these numbers conveys 6 bits of information. Let me explain what that means. Bit is the smallest indivisible unit of information. It simply means that something is or is not. A bit is either 0, which commonly means false, or 1, which sometimes means true. If we convert the 64 integers into binary numbers, where each 0 or 1 represents 1 bit, we can see that the 64 different numbers express all possible combinations of 6 bits, here denoted by the binary digits 0 and 1. Try it! Try to come up with a 6-bit binary number that isn't listed here. Can't do it? Neither can I. It's like trying to come up with an integer between 3 and 4. This is why we say that a symbol that can have 64 distinct values conveys 6 bits of information. Now, what do we first think when we see a character set with 64 distinct symbols? We think of base 64. Base 64 means that 8-bit data is transmitted using 6-bit symbols. Let me show how that works. Here we have 3 groups of 8 bits. Each 8-bit group is called a byte or an octet. These octets could represent various data in the game, such as hit points, number of hearts, or a list of collectible items. Together they just form the saved data. When we regroup these bits as 4 6-bit groups, we get base 64. Base 64 is really that simple. 3 octets are put together and regrouped as 4 6-bit symbols. The same is done with the next 4 bytes and the next, and so on. When decoding base 64, the process is reversed. 4 6-bit symbols are put together and regrouped as 3 octets. And Kid Icarus does this with its data. Let's first assemble all the data that the game could be saving in the password, and then see what it actually saves. Let's start with the easy ones. Total score. The main method of gaining score is by killing enemies. Once you beat the level, your current score is added to your totals, which does save in the password even if you get a game over. Only the total score is saved, not the current level score. Now, contrary to many other games, score actually has meaning in this game. The player's level is called endurance. At the end of each stage, the player's endurance level is readjusted to 1, 2, 3, 4 or 5, depending on whether the total score in thousands is below or at least 20, 50, 100 or 200. This level determines the player's HP max by the formula 7 plus level times 8. Internally, the game stores this number 0-based, so Pit starts at a level 0 and 4 is the maximum. However, the level does not determine the player character's strength. For that, there is another stat. The player character Pit starts at strength level 1, but he can gain a total of 4 strength upgrades up to level 5. The representation of strength in the game is arrows, and Pit gains strength by picking up an arrow he gets from a god. The amount of damage Pit does to enemies is equal to his strength level, measured in arrows. The maximum number of simultaneous arrows is 5. Internally, the game stores this number 0-based, so Pit starts at level 0 and 4 is the highest strength level he can attain. Favor counter. There is a secret counter in the game that measures the amount of heroic things you have done in the current stage. Heroic things are those that increase your score, but also acquiring power-ups, purchasing any items that aren't immediately consumed, and even entering chambers. The counter decreases when you do unheroic things, such as firing your bow, taking damage, smashing a treasure pot, or paying with credit. At certain points in the game, you will have a chance to meet a god. The Greek gods aren't interested in cowards. They will only receive you if you have been demonstrating heroism throughout the current stage. It is for this reason that I call this the favor counter. The god will grant you a new strength update if he favors you. Precisely 10,000 favor is required, although you gain 300 by simply entering the room, so 9,700 is the actual requirement. If the god appears, he will instantly give you an additional 1000 favor, although it's unclear what use that is. If you are already at maximum strength level, the god will not appear. The first chance for an audience with the god is very early in the game. Killing one of these winged snakes always gives you exactly 100 favor. Collecting the heart gives you another 100, but firing your bow loses you 10 favor. It would be possible to earn this early strength update by killing 52 tiny snakes without taking damage, assuming you don't miss very often. Unfortunately, it is only possible to kill 32 of them before the door scrolls out of view, meaning that you will be more than 3000 favors short, even if you manage to kill multiple snakes with a single arrow. How about the second quest? When you beat the game, you get to keep your hearts, total score, the 3 power-ups and all stats, but not the favor. The favor number resets to 0 when the ending begins. It is never possible to get this strength upgrade without cheating, not even in the second quest. Dying is the least heroic thing you could do, so by the time you get the password, favor will be always 0, and there is no sense recording that in the password. Hearts. Every killed enemy drops a heart, and Pit can collect them. The heart counter starts at 0, and 999 is the maximum. However, when you pay something with a credit, the heart counter may go negative. The game renders it as 0, but it keeps track of how much debt you have. The debt is not rendered anywhere, but you know that you still have debt when your apparent hearts count stays at 0 despite picking up hearts. Speaking of debt, you need a credit card to accumulate debt. You have it, or you don't. Angel feathers and mallets are collectible items that have a certain use, and the maximum for both is 99. Using mallets, you may rescue Centurion helpers to aid you in boss fights. Although there are only about 70 Centurions in total, the game limit is 99. Number of bottles. You can have either 0 or 1 bottle. However, at certain point in the game, you may purchase a barrel. A barrel may hold up to 8 bottles of healing liquid. You either have the barrel or you don't. The torch, pencil and checkbook are only valid in fortresses. Once you exit the fortress or die, these items are lost and must be reacquired, so they are not saved either. However, there are 3 treasures, relics that you acquire from the fortresses of Skyworld, Overworld and Underworld respectively, enabling Pit to fight Medusa in the last stage. When you acquire treasures, you don't get to use them right away. They are locked. It is only when all 3 have been acquired that they are unlocked together. Technically speaking, there is no reason to save the treasures at all, because you can't progress in the game without going through fortresses from which you get the treasures, whether you pick them up or not. Let's not remove them from the list yet, though. Now the power-ups. There are 3 power-ups that you may acquire in the game. These are the Flaming Arrow, the Sacred Bow and the Crystal Rod. You may acquire them in any order, and the order you acquire them in determines certain conditions required to actually use them. You see, when you acquire the item, you don't necessarily get to use it. You have the power-up, but it's not unlocked yet. So we need another set of 3 values to indicate that the power-up is unlocked. Additionally, at some point in the game, it may get stolen, and you may purchase it back from the black market. This makes each power-up a 13-state variable. When you beat the game and run through the ending, you get a chance to start a new game. This sets the second quest flag. However, as far as I know, it has no influence to anything in the game. I think the developers ran out of time to write any code for the second quest. The game also tracks the number of times you have used the continue. The only use of this counter is at the end of the game, where a number is calculated. Player level plus player strength plus 2 times 10,000 minus the number of continues times 1000. In the disk system version, this number determines which ending you get. However, while in the Western version the calculation is still performed, the result is never used. And then there are the current world and stage, which are 13 in total. Now let's see how this data fits in the password. The password was 24 symbols long, which means that it fits 18 bytes of data. Here I have laid out 18 bytes bit by bit. They are listed in varying sized groups for presentation reasons that will be evident later. Let's start with the power-up information. The power-up information is saved in a slightly different format. Only a number 0 through 3 is saved. How about the locked/unlocked status? Well, for each weapon individually, there is a second byte that indicates whether the power-up is acquired, unlocked or stolen. The power-up status information is saved in the low 2 and top bits of the first 3 bytes, and the power-up index information is saved in the remaining 2 bits of the same bytes. Next is the score. While the game caps the score at 10 million, the actual data is 24 bits long, and it's saved in the next 3 bytes. Now the number of hearts. That number maxes out at 4095, and it's saved in bytes 6 and 7. But what if the number is negative? Well, turns out that the heart count and the debt are 2 distinct variables that are saved separately. Now speaking of debt, whether you have the credit card is saved in byte 9. The next 2 bytes are the angel feathers and the mallets, both of which actually have a limit of 255 and are saved in the next 2 bytes. The maximum number of bottles is 63. The barrel is indicated using 2 bits. Normally the value is 1 if you have the barrel, but any non-zero value will do. Byte 13 stores the strength level and the endurance level, both of which have a range 0 to 15. 0 is the level that you start at for both numbers. Treasures are stored in byte 14. Each treasure is stored as a 2-bit value. 0 means don't have, anything else means have. The game internally thinks 1 as locked and 2 as unlocked, but the distinction is meaningless because in any but the final stage they are always locked if you have them, and in the final stage you will always receive them unlocked no matter what the password says. The number of Centurion helpers is a 8-bit quantity and it's stored in byte 15. The second quest flag is stored in byte 16. The number of continues is not saved. The password discards this information. Technically speaking, the game also doesn't store the current world and stage number, but it would be misleading to leave it at just that. You see, Kid Icarus, well, the original game, Hikari Shinwa Palutena no Kagami, was programmed for the Famicom disk system, and it was comprised of several program modules. Each program module was responsible for a particular thing. Some of these disk files are also data, such as graphics. What follows is a simplification, but basically the program modules were like this. There were 10 program modules, although one of them did triple duty. Each module was responsible for one particular phase of the game. Different phases had different rules. For example, Engine 2 could only scroll vertically, Engine 4 could only scroll horizontally, and Engine 3 could not scroll at all. Because some of these modules had multiple internal phases called stage numbers, there was a separate variable, a parameter to the module, which described which level data it should load. The program module number is 4-bit and the parameter is 3-bit, and both are saved in byte 16. Now there are some slots we haven't found any meaning for yet. These 2 bits here are literally not used at all. The game always puts their zeros, but it doesn't care if there's something else there. These 7 bits in slot 9, the game populates with a random number. And the 9 bits in the first 3 slots are unused and should always contain 0, but the game does remember them and reproduces them when it gives a new password, unless that power-up doesn't exist. These extra bits cause some glitches in the logic covered in the video at 2751. But I found this already too hairy to cover in full detail, so I will leave this as an exercise to the reader. And the final byte is populated with a checksum of everything before it. Well, this is the truth in the PRG0 version. Later they revised the game a little bit and released version 1. One of the changes they did was to fix a bug in version 0. You see, the power-up index is actually a 5-bit value, not a 2-bit value. When the power-up is stolen, it is removed from the list of power-ups and replaced with a remnant value that indicates whether the power-up was locked or unlocked at the moment when it was stolen. In other words, the 2 lowest bits of the power-up index have a different meaning depending on whether the item is stolen. Suppose the following scenario happened. If you had your flaming arrow unlocked, Yes, it's there, but then stolen, so it's no longer there. And you can actually see it on sale on the black market. And then you enter a new stage. Die, take a password, reset the console and enter the same password. Suddenly the game would think that you have gained the sacred bow, which you didn't have before. A lapse in the password data design leads into corrupted restoration of game state. To fix this problem, they changed the way the power-ups are saved in the password. The first 3 bytes are now different. To make sure that old passwords would not be mixed up with new passwords, they also changed the checksum into full 12 bits and reduced the random number into 3 bits. This version of the password is used in all new versions of the game, including the Nintendo Virtual Console version. Notably, however, the famous coincidental glitchy broken but valid password, Icarus fights Medusa angels, no longer works in the game. To get exactly the same game state, you need a different password shown on the screen.
Asokus fights Medusa angels.
Of course, that's no longer very pronounceable, so may I suggest another?
Retook Bamboo Pillow Gaming.
It puts you much ahead in the game with far less glitches. Not saying 0 glitches, but less glitches. If we ignore the possibility that some passwords might crash the game, there are this many distinct passwords that work in PRG0, and this many distinct passwords that work in PRG1. The number of passwords that work in either version is significantly smaller, but still a very large number. Out of these, those that decode into exactly the same game state regardless of game version, these ones consist predominantly of numbers, because the sum of all symbols must be less than 256 for the checksum to work in both game versions. Did I say that certain passwords might crash the game? If we ignore the possibility that some passwords might crash the game... Oh yes. Let's study how all these values work. The credit card and second quest flags are simply yes and no values. You either have the thing or not. No room for undefined values. Mallets, feathers and centurions are simple. Values less than 100 are normal. If the value is greater than 100, the game renders 99. However, if the value is greater than 27, that's where the function will deviate. For angel feathers, if the value is greater than 28, that's the same as if you don't have any angel feathers at all. That's because when pit falls into a pit, the game first decrements the feathers count and checks if the resulting number is negative. Normally, only decrementing 0 is supposed to produce a negative number, but because byte values 28 and 255 are all considered negative numbers, this means that byte values 29 and 255 offer nothing but false security. For centurions, the situation is similar. However, now the negative value is checked before used. So already if you have 28, that's the same if you have none, and indeed the game changes the number instantly into 0. There is some sort of safety check. If the number becomes negative for some unforeseen reason, it's changed into 0.
Lies detected.
Oh no, dang it AI. Yes, the centurions are only usable in castle levels, but whenever you enter one, the game resets the number of centurions to 0. In other words, the centurion count in your password has no effect whatsoever. Oops. For mallets, the situation is a bit different. If you have more than 28 mallets, the game lets you use one. However, after using one, the number becomes immediately 0. For bottles and barrels, the limit is 63. That's the same whether or not you have a barrel. Only the rendering and acquisition show a distinction, but the part in the game that uses the bottles doesn't care. Any non-zero value of the barrel flag is interpreted as having a barrel. The game itself only puts there 1, but 2 and 3 also work. There is no distinction whatsoever between those values. The score caps at 7 decimal digits. Using a password, it's possible to get more, but always the maximum value that gets rendered is 9999. If you acquire more score than the maximum, the value is changed into the 7-digit maximum value. The situation with hearts is fairly complicated. Firstly, the status screen and the heads-up display render the number differently. The status screen clamps the number at 999, while the HUD just renders the lowest 3 digits. The purchase algorithm is fairly straightforward. If the player has enough hearts, subtract the price. Otherwise, if the player has a credit card and no existing debt, clear the hearts and add the purchase price into the debt. The acquisition algorithm is more complicated. If the player has debt, the debt is consumed first and the hearts are not accumulated. Otherwise, the game attempts to check if the number of hearts is smaller than 999. If so, add the hearts and otherwise clamp the number to 999. However, it doesn't quite work right. While the condition does work properly in all normal game situations, it glitches if a password is used to give the player more than 999 hearts. Both the strength and endurance range from 0 to 4 in the game. However, the password can specify any value from 0 to 15. For endurance, the value is kept in RAM as is, but any value greater than 4 is treated as if it was 4. At the end of the level, the value is changed into what the game expects depending on the total score. For strength, values 0 to 4 are normal. If the value is 5, 6 or 7, the game instantly changes the value into 4. Only the low 3 bits are red. If the value is between 8 and 12, it's treated as if the value was between 0 and 4. If the value is greater than 13, it's instantly changed into 12. However, there are 2 exceptions to this rule. There are 2 circumstances where bit 3 is not masked. When determining the ending and when determining if a god should appear to give a strength upgrade. Essentially, bit 3 of strength doubles as a hard mode flag, even if that feature does not explicitly exist in the game. The 3 sacred treasures are a visual gimmick. You can manipulate the numbers to change what appears on the status screen, but to the gameplay, their effect is nil. Nothing. 0. Oh boy, the 3 power-ups you may acquire in the game are the Flaming Arrow, the Sacred Bow, and the Crystal Rod. Because this information is duplicated in the password and triplicated in the game, there are many rules that the game-consistent password must obey. If one of these rules is missed, the password is synthetic and not generated by the game. At least that is in the program version 1. In PRG 0 all bets are off. Periodically, I think every frame really, the game runs a routine that syncs these 2 arrays. It is a rather complicated process and I think it's best explained with code. As you can see, it's really quite complicated. With custom passwords, it's very easy to get these 2 arrays into an inconsistent state, despite the checks made by the game. I will leave study of the implications as an exercise to you, because I have been tinkering with this for 2 months already, and I must really get this video out. Shortly though, if the power-up index is in the range 4 to 15, the game works quite normally, but there will be graphical glitches on the status screen. There is also a 3rd array in the game, a bit mask collected from these, but it's not password relevant, so I don't cover it here. I don't understand why they went with such a complicated design. And that leaves the program module and parameter. On screen is the valid list of combinations of these 2 numbers. There are 13 valid combinations, but the data in the password may compose 28 different combinations. So what happens if the data is not one of these 13 sacred combos? Here is the table laid out in a different manner. Now let's fill in the missing rows. In modules 3, 5 and 7, the module parameter is completely ignored. You get the same castle regardless of the parameter. In module 8, the Sky Palace, the parameter is not completely ignored. It affects the color of the text being rendered in the interlude, but nothing else as far as I know. Modules 0 and 1 are responsible for the title screen animations, and they completely ignore the parameter. In module 2, 4 and 6, the valid parameters are 0 through 2. If 3 or greater is specified, the game just crashes. Module 9 begins the ending demo, regardless of any parameter value, but without music. Modules 10 through 15 crash the game. This happens because the game reads the module settings from a table that has a fixed number of entries, and if the module number is greater than 9, the game ends up reading meaningless data and putting those meaningless numbers into jump pointers, page numbers and so on. Utilization of those meaningless numbers is what leads into the crash. Kid Icarus is an underrated game. Sure, it begins really difficult, but once you get past the initial difficulty spike, the game actually becomes rather enjoyable and relaxing, except for the eggplant wizards. Sure, that's incredibly funny and somewhat exciting and scary when you think of it, but in terms of gameplay, it's quite frustrating. But that's really small compared to what's in some other games. I hope you enjoyed this tour of discovery. I sure did, even though I vastly underestimated the amount of work required to make this episode. I think in the next episode I will do a game with much less work. Maybe a Mega Man game. Who knows? See you next time.